Assalamualaikum and hi. In this video, we from Group 1 of KM30303 Electric Power and Machine Project Assignment will be presenting about the task given entitled Set up a small-scale electrical power system for common hall at a rural village in Tambunan. First of all, let's get to know our group members. My name is Muhammad Irfan and here is the list of my friends' name. These will be the contents or topic discussed in this video. So, without further ado, let's start with the introduction. The project aims to address energy challenges in the rural village of Tambunan by implementing a small-scale electrical power system using photovoltaic technology. This sustainable approach targets the common hall to provide consistent and cost-effective electricity, enhancing the village quality of life and promoting community development. The initiative also serves as a model for similar rural environments, emphasizing sustainability and community involvement through educational initiative on renewable energy. Moving on to the problem statement. The rural village of Tambunan faces challenges with inadequate access to electricity, particularly in communal spaces like the common hall. This energy deficit hinders socio-economic development and negatively impacts residents' quality of life. The project aims to address these issues by introducing a sustainable power system using photovoltaic technology which harnesses solar energy. This solution aims to overcome the limitations of the current power infrastructure, ensuring reliable and clean source of electricity for community activities, while also contributing to the overall well-being and development of Tambunan.
Hi, my name is Elvinson Eviko Anak Philip, and now I will explain about our main objectives for this project. So, the main objective is to establish a reliable and sustainable electrical power system for a common hall in Tambunan, which is a rural village area. So, the next one is our key goals for this project, which is to provide a consistent electricity through a PV system, to reduce dependence on non-renewable sources, to promote environmental sustainability, and serving as a model for similar rural settings.
Hi, my name is Nurfara Ain and I will continue to the load assumptions. First of all, we will go through to the dimensions of the common hall where we chose length is 18 meter, width is 10 meter and height is 7 meter. And the air change per hour of the common hall is 10. The area of the common hall is 180 meter per square while the volume is 1260 meter per cube or 44,496 feet per cubic. We move to the lamp specifications. This is the lamp that we have choose, which is LED high bay lamp. And the type of the lamp is LED lamp with power 100 watt. The luminous flux of the lamp is 100. The utilization factor is 0.6 and the maintenance factor is 0.8, which is good because the range is from 0 to 1. And the illuminance level is 300 lux. And last, the price is 82 ringgit and 70 cents. To find the number of lamp that we need to use in the common hall, we use lumen method where the formula is N equals to E times A over F times UF times MF, where N is number of lamp, E is the level of luminance, A area, F is the lumen output, UF is utilization factor, and MF is maintenance factor. So from the specifications informations, we put into the formula and we got 10 number of lamp that we need to use in the common hall. Next, we move to the fan specifications. The type of the fan that we use is wall-mounted fan, which is suitable for 7-meter high building. The power is 50 watt. The air delivery of the fan is 2400 watt. The dimensions is 360 mm times 450 mm times 530 mm. And last, the price of the fan is 155 ringgit. So to find the number of fan that we need to use in the common hall, first we need to find the CFM of the hall, the volume flow rate, which is volume of hall in feet times air change per hour over 60. So the answer is 7,416 feet per cubic over mean. So after that, we put in the formula of CFM of hole over CFM of fan, and we got 3.09, and we assume that 4 fan is suitable in the common hole. Therefore, we come out with the load assumptions. This table shows the common hole electric load, where the total energy of LED high bay light is 8,000, while the total energy of wall-mounted fan is 1,600. That's all from me. I will continue to the next presenter.
Next, we proceed with the equipment requirement. So before we need to find the suitable solar panels, we must do a calculation. So it is given that the average daily energy consumption is 9.6 kilowatt and the system efficiency is 80%, and also the average of the sunlight per day is 5 hours. So first thing we need to find is the daily energy production requirement, which is 12k watt hours, and also we assume the rating factor is 85%. So first we need to find the solar panel capacity, which is the energy production divided by the hours, the average hours that we get. So we can get the capacity is 2.4 kilowatt. So by considering the rating factor, which is the 85%, we can get the actual solar panel capacity, which is the 2.4 kilowatt divided by 0.85, and we can get the actual solar panel capacity is 2.82 kilowatt. So if the capacity of a single solar panel is 300 watt, the number of panels required we can get from this formula. The number of panels, 2.82 kilowatt divided by 0.3 kilowatt, and can get 9.4 panels, which is it is around 10 solar panels of 300 watt each. So the first equipment that we needed, of course, is the solar panels. As I said before, the quantity that we need is 10 panels, which one of it capacity is 300 watt, and the total capacity of the single solar panel is 2.82 kilowatt. And the next equipment is the charge controller. The capacity, how we get the capacity is from the calculation from the current generated by the solar panels, roughly at 8.33 ampere, and we times it with 10 because we have 10 panels, and after that we times it with time 1.25, so and then we can get the capacity of 105 ampere. So this is the picture of the charge controller that I get from Lazada. Other than that, we also need a battery bank. The battery bank has capacity of 24k watt hours, and the voltage, it has 48 volt and also 500 ampere hours AGM. So the calculation is based on 50% depth of discharge and 1 day autonomy, and the source is I get from photonicuniverse.com. Also the inverter, we can get the capacity is 1500 pure sine wave, and it must can withstand the power that want to light up the LED high bay light, also the wall mounted fan, and also all of this, the source is the inverter I get from the RS Malaysia. Next, we move to the overall cost of this project. As we can see here, all of the listed items until 7, including the wiring and installation, So the overall cost that we can see here is 28,150 ringgit and 11 cents.
Hello everyone, today we're delving into the world of solar battery charging circuits, a fascinating integration of components that makes solar charging a breeze. Our circuit is designed to streamline the solar charging process, combining various essential components to maximize efficiency and reliability. The main player is the solar panel harnessing DC electricity from sunlight. To prevent reverse current flow at night, we've got a trusty MBR1645G diode acting as a current limiter. The 12 kΩ resistor ensures controlled charging. And for setting the charging voltage, we have the adjustable TL431AC LP IC at approximately 13.8 volt. The head of our operation is the pulse width modulation PWM signal generated by Integrated Circuit 1, crucial for managing the switching of the MOSFET. To maintain isolation, we have the VEDI optocoupler ensuring a barrier between the high voltage and low voltage sections. The 2SC1815 transistor powers the optocoupler LED, a vital part of the circuit's safety features. And finally, the high-power IRF-Z44 and PBF MOSFET takes charge of switching the charging current to the 12-volt battery, completing our lineup of components. Now, let's see how these components work together in harmony to make solar battery charging a reality. The solar panel initiates the process, generating DC current in the presence of sunlight, kickstarting the charging cycle. The MBR1645G diode ensures electricity flows in one direction, preventing backflows at night and when the sun takes a break. The Integrated Circuit 1 produces a PWM signal dynamically adjusting the duty cycle to control the charging voltage effectively. The VEDI optocoupler driven by the PWM signal maintains isolations, protecting the control circuit. The 2SC1815 transistor triggers MOSFET switching, regulating the charging current to our 12-volt battery. This modern inverter turns 12-volt DC into 230-volt AC and is managed by an IR2153 microprocessor. Unlike the common 555 timer, the IR2153 is a special chip for MOSFETs, making the system more efficient and reliable. It uses a mains transformer with two windings to produce 12-volt and 230-volt outputs. Both the transformer and the MOSFETs need proper heat sinking for the load. The IR2153 has protection and shutdowns at low voltage to keep the inverter and battery safe.
So now I will explain about the advantages and disadvantages of using a PV system. PV system has a very high reliability and the warranty can be used up to 25 years. It has a very low maintenance cost where it doesn't require fuel to run the system. As for the disadvantages of this PV system, it has a very high startup cost and also very dependent on the availability of solar radiation in certain area. Depending on which area of the system is going to be used, it will also affect that the advantage and disadvantage of this system.
Next, I will present about the safety precaution and protection for Highland area. So the first one is use antifreeze or anti-corrosion additive in the battery electrolyte to prevent freezing or damage in low temperature. And second one is check the weather forecast and avoid installing or maintaining the photovoltaic system during thunderstorm, strong winds or heavy rains. The third one is by educate the villagers on how to use the photovoltaic system safely and efficiently, such as avoiding overloading, unplugging unused appliances, and keeping children away from the system. Next, install lightning rod or surge arrestor near the photovoltaic array and the inverter to protect the system from lightning strike. And the next one is use durable and waterproof material for the mounting structure, the wiring, and the junction boxes to prevent moisture or rust. And the last one, wear personal protective equipment such as gloves, goggles, and boots when handling the photovoltaic component, especially the battery, which may contain corrosive and toxic material.
Hello again, so next I'll be discussing regarding the impact on environment due to the usage of solar power. First, reduce carbon footprint. Solar power decreases reliance on traditional energy, lowering the greenhouse gas emission and improving air quality. Second one is conservation of natural resources. Solar energy reduces dependence on finite resources, preserving local ecosystem and preventing habitat destruction. Next, preservation of biodiversity. Solar power minimizes impact on the ecosystem, contributing to the preservation of plant and animal species in the region. And the fourth one is noise reduction and visual harmony. Solar panels operate silently, so it will reduce the noise pollution and contribute to improved visual aesthetic around the common hall. Furthermore, mitigation of urban heat island effect. Solar panels help mitigate the urban heat island effect, maintaining more moderate temperatures near the common hall for a sustainable environment. Next, water conservation. Solar power systems require less water compared to some conventional methods, contributing to efficient resource use. And the last one is potential positive social dynamics. While not a collaborative effort, the project may spark awareness and discussion about sustainable energy practices within the community, laying the groundwork for future collaboration and increased environmental consciousness. That is all for me. I'll pass the mic to Elvinson. Thank you.
As a conclusion to this project, we managed to design and implemented a solar power system for the common hall in Tambunan. However, we need to take note that some of the value that has been made are out of our assumption. Therefore, a future improvement need to be done, such as a proper research and more detailed information need to be given. That's all from us. Thank you.